Hafaday. Today we're going to be talking about rational expressions. And rational expressions are really just expressions in the form of fractions. You might also hear algebraic fractions. And for this video, we'll cover simplifying, multiplying, dividing, and combining rational expressions, as well as looking at simplifying complex rational expressions and rationalizing denominators. So first, let's look at simplifying rational expressions. And there's two steps to this. The first would be to factor the numerator and the denominator, and we do these two separately. And the second step would be to divide out or cancel any common factors. I always suggest to students or anyone I talk to about this to try to factor the side that's easiest to factor first, because it could give you an idea of what a factor of the other one might be. So looking at this one, I can see that the denominator, x squared minus 16, is really easy to factor because I can use the difference of squares formula, right? So I would do that one first. So I know this is going to come out to something. I'm actually going to leave that numerator blank for now. Over x plus 4, x minus 4, right? I'm factoring that denominator to x squared minus 16 is equal to x plus 4 times x minus 4. I might do this factoring of this other one on the side just to make sure. So we have 3x squared minus 14x plus 8. We do the same thing we always do. We look at the signs. We're looking for a sum, and they're going to be the same sign, right? And they're both going to be negative. Factors of 3x squared are 3x and x. Factors of 8, we have 2, 4, and 1, 8. Okay, and then for me, the reason why I like this one is because I can already say, okay, there's only one to choose on this side. However, instead of having to guess and check for which one to use, 2, 4, or 1, 8, I'm going to probably guess that it might be 2, 4, and it's probably going to match one of these. Since they're both negative, maybe I'll put x minus 4 for 1, right? And then obviously the next one's going to just be 3x minus 2. And I'll do the same thing we always do. We do that cross multiplication there to just check our work. Negative 2x, negative 12x comes out to negative 14x. So I know that this is the correct factorization of that trinomial. So we have x minus 4 times 3x minus 2. From there, I've already done the first step. The second step, I would cancel out any common. So I see that both the numerator and the denominator have x minus 4. So I can cancel both of those. Which leaves me with 3x minus 2 over x plus 4. I always suggest you take one last look, see if there's anything else you can factor out or cancel. There's nothing, so this is our final answer. Moving on now to multiplying rational expressions. And you're pretty much just doing this kind of the same way that you would do a normal fraction. So when we're multiplying fractions, we multiply the numerators, multiply the denominators, and then try to simplify it. So for this one, what I'm going to do is write the product of the numerators over the product of the denominators and reduce the lowest terms. Essentially, we're doing the exact same thing. So what I'll do now is multiply all my numerators. 4 times 10 gives me 40. X squared times x is x to the third power. And then we have y. All of that's going to be over 5 times 12 gives us 60. X squared, y to the 6th power. Okay, so that was all multiplication. Now what we're going to do is cancel whatever we can. So I'm looking at this and I'm seeing that 40 and 60, both those numbers are divisible by 20. So I know this is going to be 2 and 3. X cubed and x squared, the smaller one's going to be canceled out completely. This x to the third power is going to become x to the 1. Y and y to the 6th, the y is canceled out. This becomes y to the 5th power, which leaves me with 2x over 3y to the 5th power. Now we're looking at something a little bit more difficult. So for this one, I might actually want to see if I could factor out stuff first and then see if there's anything I could cancel before I actually multiply them all together. So I'm looking at this first one, negative 4x plus 12. I know I can factor out 4 or negative 4. So maybe I'll factor out negative 4. Just so I can have that x be positive. And then denominator, I'll factor out 3. Multiplied by 2x plus 6 becomes 2 times x plus 3, factoring out 2 from that. In the denominator there, we can factor out 4, x plus 5. Okay, now I can already see there's things I can cancel out. This 4 and this 4, that can just become negative 1, right? Then we have 1 there, that's fine. The x plus 3 and x plus 3 can also cancel. 2 and 3 can stay there. And then I'll actually just write what I have left, which leaves me with negative 2, because negative 1 times 2 is negative 2. Then we still have that x minus 3 here, over 3 times x plus 5. Again, I'll look at it one more time to see if there's anything I can cancel out. There's nothing. This is a good final answer. We're moving pretty quickly through these. Now we're going into dividing rational expressions. When we're dividing, again, we're doing it the same way we do with fractions, where we multiply by the reciprocal of the divisor. Basically, I am keeping my first fraction the same, and then flipping the second one, and then just following the rules of multiplication. So for this one, I know it's going to be a squared b over c divided by ab over c squared. I know because of the rule that we're going to have to actually write it as a squared b over c multiplied by the reciprocal of that divisor, my second one. So it's going to be c squared over ab. From here, I'll do my canceling that we like to do. So this c and the c squared, the small one's gone. This becomes c to the first power. B is canceled completely. The smaller exponent of a is gone, so this becomes a to the first power on the top. Writing carefully what we have left. We have an a in the numerator. We also have a c there. And there's nothing left in the denominator, so it's just a c. Got that a little bit nicer. AC. When we have ones that are a little bit more complicated, what I'll do is I'll flip it, and then again, I'm going to factor out each of them, see if there's anything I can cancel, and then combine them after that. So for this one, I'm actually going to rewrite it. So we have 6x squared minus 6. If you want to jump straight to factoring from here, you can. But here, I'm going to multiply it by the reciprocal. X squared plus 4x plus 4 over x minus 1. From here, what I'll do is start factoring out things. So I know 6x squared minus 6, I can factor out 6. And I'm left with x squared minus 1. But looking at this again, I know x squared minus 1 is actually easily factorable. It's a difference of squares. It's going to come out to x plus 1 times x minus 1. So I'm actually going to change that to x plus 1, x minus 1. Over x squared plus 3x plus 2. This is another one that's easy to factor. Factors of 2 that give me a sum of 3 are just 2 and 1. So it becomes x plus 2 times x plus 1. Multiplied by x minus 1. I cannot factor that out. X squared plus 4x plus 4. Factors of 4 that will give me a sum of 2, or sum of 4, are 2 and 2. So it's x plus 2 times x plus 2. From here again, cancel what we can. There's an x plus 2 down here. I'll factor out one of the x plus 2s up there. X minus 1, x minus 1. And then from there I can just put my answer together. If you want, you can actually multiply it back, but I would just leave it as it is. 6 times x plus 1 times x plus 2. Ooh, actually, this one's a good lesson. So for me, I actually missed. There's actually one more thing I can cancel out. Always look back at your answer to see if there's anything left that you can cancel out. There's still this, x plus 1. So this is actually going to just be 6 times x plus 2. Or its equivalent. But this is perfect. Okay. Moving on now to looking at combining rational expressions. And when I say combine, I mean either add or subtract. What we first need to know how to do is find the LCD of rational expressions. And there's 3 steps to this. Completely factor each denominator. So looking at these 3 ones that we have, 1 over x squared minus 4, 1 over x squared, and 1 over x squared minus 4x, I'm going to completely factor each of my denominators, right? So I have x squared minus 4. I'm going to say, okay, x squared minus 4 is, I'll just write them on the side over here, is going to be x plus 2 times x minus 2. And I know this again because of difference of squares. X squared, I know it's just going to be x times x. All right, that's my factors of that. X squared minus 4x. I can factor x out of that. X times x minus 4. Okay, so now that I've completely factored each denominator, I can move on to step 2, identify the different factors that appear. So even though some might be repeated throughout the different ones, but I want to have at least one of each. And the LCD is the product of the factors. Each factor should be used the maximum times it occurs in any one denominator. And what this means is really that, for example, if I look at the factor x, it appears in both x squared and x squared minus 4x as one of the factors. But for my LCD, I have to list it as x squared because that's the most times it occurs in every one. So your LCD should be divisible by each of your original denominators. So x squared cannot go into x, but it can go into x squared. So I need to keep that x squared there. So my LCD is going to be, I want to make sure I keep hold of a bunch of these, right? So we have the x plus 2, x minus 2, and x squared, and then this x minus 4 is also new. And it's nice to keep the x squared at the front. And that becomes our new denominator for when we combine them. Now let's look into combining rational expressions. The first step would be to find the LCD of the fractions. Then we would write their equivalent with the LCD as the denominator, and then just combine the numerators in the same way that you would just add fractions, right? You keep the denominator, add the numerators. So combine 5x over y squared and 6 over xy. So first I want to do is find the LCD, right? So I know my two terms are y squared is going to be y times y. Oops. Y and y, right? And then we have xy, which is just x times y, right? We have x and y as our stuff. So of course I need to have at least one x, and I need to have the two y's. So my LCD is xy squared. So now when I write it as its equivalent with the new denominator, I want to look first at, okay, what was it beforehand? So I had 5x over y squared. My LCD is now xy squared, so I'm going to multiply this now by x to get there, right? So whatever I do to the bottom, I need to multiply to the top, x over x, plus 6 over xy. What am I missing from my LCD? I have to multiply both sides by y to be able to get to that xy squared. This simplifies to 5x squared over xy squared plus 6y over xy squared. If you jump straight to this step, that's perfect. If you don't, that's fine too, right? We always take all the steps we need. From now that we have the same denominator, I'll just combine my numerators. 5x squared plus 6y over xy squared. If you can reduce anything from there, you can. However, this one we cannot, so we'll leave our answer like that. For this next one, we're actually going to be looking at something a little bit more difficult. But again, we're going to find it the same way, finding our LCD first by factoring each of my denominators and then seeing what their factors are. So I'll do this on the side again. So we have LCD. That's what we're going to use later. So we have x minus 5 squared is obviously just x minus 5 times x minus 5. When we have x squared minus 4x minus 5, I'll factor this. The factors of 5 that give me a difference of -4 are -5 and +1. So my LCD, I'm going to have two x minus 5s because that's the highest number that occurs in any one denominator. And then we have this x plus 1 that's not accounted for anywhere. So we have the x plus 1. So it's going to be x minus 5 squared times x plus 1. And again, what I'm going to do is look at these ones and see what each of them are missing. So originally I have x minus 3, x minus 5 squared. In order to get it to our LCD, I need to multiply it by x plus 1 on both the numerator and the denominator. And when we do this, make sure that you put parentheses on the first and the last. So x minus 3 should be in parentheses. Minus x minus 2, and I could put the factored version here. We have x minus 5 times x plus 1. It was missing another x minus 5, so I'll multiply that to, again, both my numerator and denominator. Okay, next step is to FOIL each of these out. You can do this on the side or all together. In order to make it a little bit faster, I'll just do it pretty quickly. I'll go to its simplified version. So x minus 3 times x plus 1 FOILed, it would become x squared minus 2x minus 3 in parentheses minus x minus 2 times x minus 5 becomes x squared minus 7x plus 10. All over the one denominator. X minus 5 squared times x plus 1. I'll combine these by first distributing that negative sign, right? I do it as if I'm just combining polynomials, right? Subtracting polynomials. I'll distribute that negative sign. And that would change the sign of everything in the inside, so it becomes x squared minus x squared, like this. So I'll rewrite it. It becomes a negative x squared, positive 7x, negative 10. Then we'll combine all of those over x minus 5 squared times x plus 1. X squared and x squared are canceled out. Negative 2x plus 7x, and then negative 3 minus 10. We have 5x. Negative 3 minus 10 becomes minus 7. Oh, sorry, that becomes negative 13. My bad. Over and again, take one last look. Is there anything I can factor out or cancel? And there's nothing. So this will be our final answer. Okay, so now we're moving into complex rational expressions. This is basically when we have a fraction within a fraction, like this shown here. We're going to go over one of the ways to approach it, and that would be to multiply both sides of it by the LCD of all of the denominators within the fraction. So we'll do this now. So we're looking at y over x, 1, y over x again, and x over y squared. So these are my different ones. And what I'm going to do is actually interpret that as 1 over 1. And I don't really care about the sign at this point because I'm really just trying to get the factors in. And if positive or negative, it doesn't really matter. So we have this, x, 1x, and y squared. All my denominators, they're already in pretty simple terms. I'm just going to find the LCD. So the LCD of all of these is going to be, we need at least one x and a y squared. So what I'm going to do now, once I found that LCD, is multiply it to both my numerator and my denominator. So I'm going to rewrite this. And multiply all of this by xy squared. And what this is going to do is actually, it's going to cancel out all the fractions in the inside, and then we're just going to have one fraction bar, which will make it a lot easier for us. And for this one, I'll multiply that in. So y times xy squared over x, right? So we multiply that. I'm going to go straight into multiplying them, actually. This becomes y times xy squared is going to be xy cubed, right? We have that over x minus 1 minus xy squared over y times xy squared. We know it's going to be xy cubed over x minus x times xy squared, which is x squared y squared. We're really just distributing that, right? And our denominators will always stay the same. Okay, and from here, now we can cancel things out. This x will cancel this. This x will cancel this one. We have that y squared, so that's going to cancel. Then I'll just write everything that's left over and then check one last time if there's anything I can factor or simplify. So we have a y cubed minus xy squared over y cubed minus x squared. And then actually looking at this, I can actually factor out y from my numerator. However, it's not going to cancel anything in the denominator because I can't factor out anything from my denominator. So you can factor out the y if you want. Otherwise, we can just leave it like this. And that was our simplifying of that rational expression. And lastly, we're going to look at rationalizing denominators. When we have a radical in our denominator, we have to rationalize it. And we do this by multiplying the numerator and the denominator by the conjugate of the denominator. So when you have something like this square root of x minus 2, its conjugate is actually going to be square root of x plus 2. We just change the sign that's in the middle. I apologize for my dog barking. Okay, so my conjugate, we said was square root of x. And what it's going to do is cancel out the radical in our denominator. Okay, so when we write this as 1 over root x minus 2, and I'm multiplying both my numerator and the denominator by my conjugate. Root x plus 2 over root x plus 2. And notice that we're going to be doing a lot of FOIL. We're always foiling, right? So you're going to FOIL this. The numerator is just going to stay root x plus 2. The denominator, I'll FOIL that. If you want, I can try to show the foiling on the side over here. I'll put it in yellow. So we have root x minus 2, root x plus 2. Root x times root x, we know is just x, plus 2 root x, minus 2 root x. Negative 2 times 2, we have negative 4. So this 2 root x and the negative 2 root x will actually cancel each other out, which gives us x minus 4. See, and it turns out really nicely. If you can factor anything else, go for it and cancel, but this one is actually our final answer. Now we have the last example. one that's a tiny bit more, we have to factor or FOIL both the top and the bottom. So we're going to again find our conjugate. The conjugate is going to be root x minus root 5. Okay, so I'm going to rewrite this. 3 plus root x over root x plus root 5 times root x minus root 5 over root x minus root 5. I'll FOIL both the top and the bottom. This leaves me with 3 root x first, outside minus 3 root x, or 3 root 5, I mean, inside, plus root x times root x is just x. Root x times negative root 5 is going to be negative root 5 root x. All over. FOIL the bottom. Root x times root x is going to be just x outside. Root 5 root x inside plus root 5 root x. And last, root 5 times root 5 is going to be 5. Simplifying and canceling where I can. This negative and positive are going to cancel each other out. Then I'll combine whatever I can. So we have 3 square root x minus 3 square root 5 minus x minus square root of 5 times square root of x is just the square root of 5x. All over x minus 5. So actually, even though my numerator looks kind of weird, there's actually nothing that we can cancel or combine there. So what I'm actually going to do is leave this as my final answer. As long as my denominator is rationalized, which it is. There's no more radical in my denominator. And that's it for the lesson. I know it's pretty heavy stuff, but of course things get easier when we practice them more. So good luck.